Right, I'm back, and you've definitely got to fasten your safety belts for this one. This is the most horrific rule. I'm doing two rules that are together, they're linked together in a special way you'll see in a minute. As is usual, let's go back to y equals x squared, my generic function. There it is, 6 squared 36 done. Here I've got the graph of y equals open bracket 2x and then square it. Not 2x squared, it's 2x. So take the x values, double them, get your answer, then square it. Okay? And the last one is, if you look at the equation, y equals open bracket 3x and then square it. Now I know this is actually 4x squared and 9x squared, I know that, but I'm not looking at vertical stretches at the moment. I'm looking at squashes in the x direction or stretches in the x direction rather than elongate in the y direction. We'll see how this pans out in a minute. So let's just turn over on the page, see how this looks. So I'm going to identify y equals x squared, y equals 2x squared, and y equals 3x squared. Alright, so we're going to go for. So turn over. Now that's clearly y equals x squared because if x is 6 and y is 36, then I've merely squared the 6. So that's going to be y equals x squared. This one's going to be y equals open bracket 2x squared. Well, let's just test it, shall we? If x is 6, and there it is, 2 6s are 12, and 12 squared is 144. I've identified it. Therefore, please trust me. The last one is going to be y equals open bracket 3x squared. I'm deliberately not going to call these 4x squared and 9x squared because this is going to highlight a different rule. Again, it's a little bit small there, so this is what it's saying. This is the transformation. I've got my generic y equals some sort of function of x, in this case y equals x squared. Now what I'm going to do to this is to take it and call it y equals function of ax. So in other words, I'm going to do something to the x first and then apply the function to it. Right, let's see what's happened. So what's the a value worth? Well, when y equals x squared, it's just 1x squared. When y equals when y equals 2x bracket squared, then clearly the a value is 2. So I'm going to investigate what happens when a equals 2 and clearly when a equals 3. So what's going to happen when a is 2 and the a is 3? Well, let's study it. Very hard to see. I want to highlight using the red little pen like that. Now look, I've gone from 636, which is the standard coordinate for the y equals x squared graph, when x equals 6, y equals 36. I've been transformed from 636 to, can you see that one? 336. So I've stretched it in the x direction this way, and in the same way I can say that I've taken my minus 636 and transformed it to the position of minus 336, and that's gone that way. It's as though I've taken my x squared graph and gone like that, and I've not taken it and gone like that, I've squished it inwards. Okay, so 36 and 36 match, but the 6 on the x has become a 3 on the x after the transformation. So how do you describe it? You simply divide the x coordinate by the value of a, but leave the y coordinate unchanged. Alright, so let's reiterate. You divide the x coordinate by the value of a. Okay, so 2x, so divide it by 2. So 636 becomes, half of 6 is 3, 336. And the net effect is to squash the graph closer towards the y-axis. But I'm squashing it in the x direction, not in the up and down y direction. Similarly, minus 6 becomes minus 3 when I halve it. Why is it halved? Because I'm dividing the x coordinate by the a value and the a value was 2, so I'm dividing by 2. So going from 6 to 3, that's called a stretch in the x direction by a scale factor of 1/2. Okay, I have halved the x. Let's just check how the book does it. Yeah, I'm happy with that. Dead easy. Well, it's a start. It's not that easy. Now, the hard thing is trying to draw what's going to happen next. I've shown you that going from x squared to 2x squared means you take the x value for each coordinate and halve it, and that has the effect of squishing in the graph nearer towards the y-axis, although I'm stretching in the x direction. I now want to go see what happens when I apply 3 times x and then apply the function. Sorry, the function is to multiply by 3 and then square. So let's use this thing again, use a different colour. It'll be very hard to see, but let's just go for it anyway. I want to go from 636 right the way across to 236. Very hard to draw, so sorry. Live with it. I've taken my 636 and transformed it to the position right there of 236. So I've still squashed my graph even more from this dark blue x squared graph to this black y equals 3x squared graph. So what's happened? I've gone from 6 to 2. I've squashed it even more. If you like, I'm going to go from -6 to -2 in that direction. There it is, from -6 to -2. So that's the position there directly above that coordinate, and there that is. So what have I done again? I'm dividing the x coordinate by the value a, but this time I'm dividing by 3. What is 6 divided by 3? Answer 2. So I'm going from 636 down to 236, because 6 divided by 3 is 2. I'm going from -6 divided by 3, hence -2. So from -636 to -236, and that has the effect of squashing it even more. So how would I describe that blue arrangement here? I'll write it in blue. It's called a stretch in the x direction by a scale factor, oops, I forgot to write the C in there, by a scale factor of 1/3. I effectively divided by 3 all the x coordinates, and they became 1/3 of the size. So for example, 6 becomes a 2, can't see any more, but I can readily work with. No, I haven't got any more. So that's it. If I work down the page here, then I've got all my 3 graphs involving the coordinate 6, involving the coordinate 3, involving the coordinate 2. It's quite easy to see. So alright, so let's just revise that one. I've got the generic y equals some sort of function of x. What I do now is to multiply by x value by a certain value, and that's my function applied to it. So y equals x squared may become y equals 2x squared. There it is, y equals x squared. My generic trial graph becomes y equals 2x squared, and of course that 2 is my a value. And here I've got y equals 3x squared, and that 3 is of course my a value. How do I transform x squared into 2x squared? I divide my x coordinate by 2, so my 6 becomes 3, but the y is unchanged. So 636 becomes 336. How do I transform my x squared into 3x squared? I divide my x coordinate by 3. So 636 becomes 236, because 6 divided by 3 is 2, and that will work in the negative direction as well. -6 divided by 3 is -2, hence the coordinates -2, 36 right there that I highlighted earlier. So this is all about stretching graphs not in the y direction but in the x direction, and it will push them nearer to the y-axis as I push them, as I squash the graph along the x-axis like that.